When a breaker in an apartment panel doesn't cut power even when turned off, it indicates a potentially dangerous situation that requires careful troubleshooting. Firstly, verify that you have the correct type of General Electric apartment panel, as not all panels are compatible with main disconnect kits. Using an incompatible kit can lead to unexpected electrical behavior. Secondly, turn off the main power from the basement disconnect. Open the apartment panel and meticulously check all wire connections to the main breaker, neutral bar, and ground bar. Those connections are a frequent cause of power leakage, allowing current to flow even when the breaker is in the off position. Pay close attention to the tightness of screws and the integrity of the wire insulation. Thirdly, remove the main breaker from the panel. Visually inspect it for any signs of damage, such as cracks, burns, or discoloration. These signs suggest a faulty breaker. Reinstall the main breaker, ensuring it is fully engaged and seated correctly in the panel. Fourthly, using a non-contact voltage tester or multimeter, carefully test for voltage on the load terminals of the main breaker. With the breaker turned off, there should be absolutely no voltage present. If voltage is detected, it confirms that the breaker is not fully disconnecting the circuit. Fifthly, inspect the busbar inside the panel for any signs of corrosion, damage, or foreign objects. A damaged busbar can create unintended electrical paths, allowing power to bypass the main breaker. Clean any corrosion carefully with a wire brush and ensure no debris is present. Sixthly, check the neutral wire connection from the apartment panel to the basement disconnect. Ensure it is securely connected and not loose. A loose neutral connection can cause the circuit to remain energized even when the breaker is off, creating a hazardous condition. Seventhly, if all previous steps have not resolved the issue, consider replacing the main breaker with a new one of the same amperage rating. A defective breaker might not be fully opening internally when turned off. Make sure the replacement breaker is UL listed and designed for use in your specific panel. Remember to always prioritize safety when working with electricity. Before commencing any work on the electrical panel, always turn off the main power from the basement disconnect to de-energize the circuit. Wear proper safety gear, including insulated gloves and safety glasses to protect yourself from potential electrical hazards. If you are not comfortable troubleshooting electrical issues or lack the necessary experience, it is highly recommended to contact a qualified electrician for professional assistance. Incorrectly diagnosing and repairing electrical problems can lead to serious injury or property damage. A non-contact voltage tester is a valuable tool for quickly identifying the presence of voltage without making direct contact with electrical conductors. When using a non-contact voltage tester, hold the tip of the tester near the wire or terminal you want to test. If voltage is present, the tester will typically light up or emit an audible beep. A multimeter is a more versatile tool that can measure voltage, current, and resistance. To measure voltage with a multimeter, set the meter to the appropriate voltage range, typically alternating current volts, AC volts for household circuits. Connect the black lead to a known ground and the red lead to the point you want to test. The meter will display the voltage reading. When inspecting the busbar, look for signs of corrosion, which appears as a white or greenish deposit on the metal surface. Use a wire brush to gently remove any corrosion. If the busbar is severely damaged or corroded, it may need to be replaced by a qualified electrician. When checking wire connections, ensure that the wires are properly inserted into the terminals and that the screws are tightened securely. Loose connections can cause arcing, which can generate heat and potentially start a fire. The neutral wire is typically white or grey and is connected to the neutral bar in the panel. The ground wire is typically green or bare copper and is connected to the ground bar in the panel. When replacing the main breaker, ensure that the new breaker has the same amperage rating as the old breaker. The amperage rating is typically printed on the breaker handle. Using a breaker with a higher amperage rating can overload the circuit and potentially cause a fire. If you are unsure about any aspect of troubleshooting electrical issues, it is always best to consult a qualified electrician. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and your property. In summary, the steps to troubleshoot an apartment panel where the breaker won't cut power are: firstly, verify the circuit panel type. Secondly, check wire connections. Thirdly, inspect the main breaker. Fourthly, test load terminals. Fifthly, check the busbar. Sixthly, inspect the neutral wire. And seventhly, replace the main breaker if necessary. Remember to always prioritize safety and consult an electrician if you are not comfortable performing the work yourself. Now, expanding on these points further, let's delve deeper into the intricacies of each troubleshooting step. Firstly, the verification of the circuit panel type is paramount. Not all General Electric apartment panels are created equal. Some are designed to accept main disconnect kits, while others are not. Installing a kit on an incompatible panel can lead to a cascade of problems, including the issue you're currently experiencing. Consult the panel's documentation, or contact General Electric directly with the model number of your panel to ascertain compatibility. Secondly, the meticulous examination of wire connections cannot be overstated. Turn off the main power at the basement disconnect before even thinking about opening the panel. Once the power is off and verified, open the panel and carefully inspect each and every wire connection associated with the main breaker, neutral bar, and ground bar. Look for loose screws, frayed wires, corroded terminals, and any other signs of compromised connections. A loose connection creates resistance, which generates heat, leading to further degradation of the connection and potentially a fire hazard. Thirdly, the main breaker itself warrants a thorough inspection. Remove it from the panel and scrutinize it for any physical damage. Look for cracks in the housing, burn marks, or discoloration. These are telltale signs of a breaker that has been stressed beyond its limits and is likely malfunctioning. Even if there are no visible signs of damage, the breaker could still be faulty internally. Reinstall the breaker securely, ensuring it snaps firmly into place. Fourthly, testing the load terminals with a non-contact voltage tester or multimeter is crucial in determining if the breaker is truly doing its job. With the breaker in the off position, there should be absolutely no voltage present in the load terminals. If voltage is detected, it means the breaker is not fully isolating the circuit, and current is still flowing, which is a dangerous situation. Exercise extreme caution when using a multimeter, and ensure you are familiar with its operation before proceeding. Fifthly, the busbar, that conductive strip inside the panel that distributes power to the breakers, is another potential culprit. Inspect it carefully for any signs of corrosion, damage, or foreign objects that could be creating an unintended electrical path. Corrosion can impede the flow of current and create heat, while damage or foreign objects can cause short circuits. Sixthly, the neutral wire connection is often overlooked, but it's just as important as the hot wire connections. A loose neutral connection can cause a variety of electrical problems, including the circuit remaining energized even when the breaker is off. Check the neutral wire connection at both the apartment panel and the basement disconnect, ensuring it is secure and free of corrosion. Seventhly, if all other troubleshooting steps have failed to identify the problem, replacing the main breaker is a logical next step. Breakers can and do fail, and sometimes the only way to know for sure is to replace it with a new one. Ensure you purchase a breaker that is the same amperage rating and type as the original. Using the wrong breaker can create a dangerous situation. Always remember the safety precautions. Before working on any electrical equipment, turn off the power at the main disconnect. Wear safety glasses and insulated gloves to protect yourself from electrical shock and arc flash. If you are not comfortable working with electricity, or if you are unsure about any aspect of the troubleshooting process, call a qualified electrician. Electricity is a powerful force, and it should be treated with respect. Furthermore, let's elaborate on the potential causes of each of these issues. Loose wire connections can occur due to several factors, including vibration, thermal expansion and contraction, and improper installation. Over time, the screws that hold the wires in place can loosen, creating a gap between the wire and the terminal. This gap increases resistance, which generates heat, leading to further loosening of the connection. A faulty main breaker can be caused by a variety of factors, including age, wear and tear, and exposure to excessive current. Over time, the internal components of the breaker can degrade, causing it to fail to trip properly or to remain energized even when it's in the off position. A damaged busbar can be caused by corrosion, physical impact, or overheating. Corrosion can weaken the busbar and reduce its ability to conduct electricity. Physical impact can bend or break the busbar, creating a short circuit. Overheating can melt the insulation on the busbar, exposing the bare metal and creating a shock hazard. A loose neutral wire connection can be caused by the same factors that cause loose hot wire connections. In addition, neutral wires can sometimes be undersized, which can cause them to overheat and loosen over time. When troubleshooting electrical problems, it's important to be systematic and thorough. Start by identifying the symptoms of the problem and then use a process of elimination to narrow down the possible causes. Always check the simplest things first, such as loose wire connections and trip breakers. If you're not able to identify the problem yourself, call a qualified electrician. They have the training and experience to diagnose and repair electrical problems safely and effectively. In addition to the steps outlined above, there are a few other things you can check when troubleshooting an apartment panel where the breaker won't cut power. Firstly, check the wiring diagram for the panel. This diagram will show you how the panel is wired and can help you identify any potential problems. Secondly, check the voltage at the panel. The voltage should be within the range specified by the manufacturer. If the voltage is too high or too low, it could be causing the breaker to malfunction. Thirdly, check the amperage draw on the circuit. If the amperage draw is too high, it could be overloading the breaker and causing it to trip. Fourthly, check for any signs of water damage in the panel. Water damage can cause corrosion and short circuits, which can lead to a variety of electrical problems. Finally, if you've tried all of these troubleshooting steps and you're still not able to identify the problem, it's time to call a qualified electrician. They have the tools and expertise to diagnose and repair even the most complex electrical problems. And always remember the critical importance of safety first. Electrical work is inherently dangerous, and it's essential to take all necessary precautions to protect yourself from electrical shock and arc flash. Always turn off the power at the main disconnect before working on any electrical equipment. Wear safety glasses and insulated gloves to protect yourself from electrical hazards. And if you're not comfortable working with electricity, call a qualified electrician. Your safety is always the top priority. In conclusion, troubleshooting an electrical panel requires a systematic approach, a thorough understanding of electrical safety, and a willingness to seek professional help when needed. By following the steps outlined above and taking the necessary safety precautions, you can safely and effectively troubleshoot most electrical problems. However, if you're ever in doubt, don't hesitate to call a qualified electrician. They're the experts, and they can help you resolve any electrical issues you may be experiencing.